Hi everyone, and thanks for joining our webinar. Today, I'd like to talk about how Apacer's industrial control SSD solutions assist 5G networking. Let's begin with a market overview. Have you ever wondered why 5G attracts so much more attention than previous generations of communication technologies? Well, it's mostly because 5G wants to meet the needs of industrial development and has a wider range of applications. Its three major features, ultra-high speed, low latency, and multi-connection, enable the industrial field to move from the traditional industrial age to the intelligent age. How fast is 5G? A 1-hour 4K video takes about 3 to 5 minutes to download on a 4G network, but it can be downloaded in less than 10 seconds on a 5G network. Such high speed can accelerate the realization of AR, VR, the metaverse, and other applications. These two features, multi-connection and low latency, are mainly used to help enterprises accelerate their digital transformation. As we often hear about smart technologies, smart factories, medical care, cities, cars, etc., the connection between things is accelerated, and everything can be realized thanks to a stable 5G network. Nowadays, most major enterprises are actively carrying out digital transformation. The digital transformation we are talking about now is not about electronic documents or global human-to-human connections, as in the early years, but a further Internet of Everything. This covers factory equipment, medical equipment, cars, and etc. However, in order to achieve an IoE, high reliability 5G network equipment will first be required, so that real-time data can be collected and transmitted to the back end for big data analysis and AI analysis. These devices include the CU-DU system in the ORAN architecture of the 5G telecommunications system, as well as the SD-WAN, firewall, router, switch, and other important network nodes used in the enterprise network, all of which require high reliability and durability. Therefore, the process of maintaining 24/7 continuous normal operation of equipment while reducing the risk of hacking and managing remote equipment will be important issues. And people often talk about AI, the Internet of Things, and 5G. What is their relationship? One can imagine that AI is the brain for making judgments, IoT is the senses for collecting data, and 5G is the nerves, that is, the road for fast streaming. Without a stable infrastructure, everything is just empty talk. Let's move on to the challenges of 5G networking. First of all, the equipment is exposed to the challenges caused by extreme weather and pollution. Then there's security, which covers cases such as hacking, firmware updates, etc. What's more, the writing of a large amount of small file logs poses a challenge to the durability of the storage device. Finally, network devices are deployed in large numbers all over the world. Remote management and disaster recovery therefore also become important issues. Next, let's explain how Apacer's industrial SSDs assist the challenges faced by 5G networking. We talked about the challenge posed by weather and pollution. Apacer's solution is to employ wide temperature resistant and anti-sulfuration SSDs. As for write-intensive challenges, the answer is our SLC LiteX technology, with its ultra-high endurance. To keep hackers out, we introduced signed firmware technology. And to make remote management and disaster recovery easier, we created the Core Snapshot backup and recovery technology. Anti-sulfuration is first on our list. There are other anti-sulfuration products on the market, but Apacer's is the first to pass the industry's G3 level ANSI ISA 71.04 air corrosion certification test. That really sets it apart. What does that certification mean in the real world? Well, different operating environments contain different amounts of sulfur in the air. If the indoor or outdoor air quality contains high concentrations of sulfur gases, such as hydrogen sulfide and sulfur dioxide, it will easily cause corrosion of electronic equipment, thereby affecting the service life. The ANSI has classified the G3 level explained here on the chart as harsh, where there's a high probability that corrosive attachment will occur. Corrosion thickness and the rate of airborne contaminants measured from a metal coupon of pre-treated pure copper and a pure silver coupon exposed to the terminal environment for a period of 1 month. Any equipment tasked with running in such an environment will benefit greatly from Apacer's anti-sulfuration protection. 2 accelerated corrosion tests are performed: a sulfur vapor test and a mixed flow gas test to effectively verify whether there will be any corrosion failures during the product warranty period. For the sulfur vapor test, the corrosion gas is sulfur, which is suitable for the corrosion of silver. For the mixed flow gas, the corrosion gas contains hydrogen sulfide, sulfur dioxide, and others. And it is suitable for the corrosion verification of copper. Apacer's anti-sulfur SSDs are certified to the G3 level through these 2 tests. Up next is SLC LiteX. As a brief introduction, I'd like to give you some fundamental information about how flash works. The NAND flash characteristic is erase before write, and PE is the abbreviation for program erase. This means the times of erase-write cycles each cell can endure. First is SLC, known as single-level cell. This chip stores 1 bit of data per cell, offers extremely high reliability, and offers 60K PE endurance, but is much smaller in overall capacity. Next is MLC, known as multi-level cell. It stores 2 bits of data per cell, offers twice as much capacity compared to SLC, is much lower in pricing, and offers 3K PE cycles. The last one is TLC, also known as triple-level cell. TLC stores 3 bits of data per cell, is lowest in pricing, is largest in density, and is now widely adopted in consumer markets. PE cycles range from 500 to 1,000 times. Our SLC LiteX is based on 3D NAND technology, and the central concept is to make 3D TLC behave like SLC. By doing so, only 1/3 of capacity is accessible to users. The other 2/3 of physical capacity will be utilized by firmware algorithms for data placements, background handling, and performance improvements. Therefore, cell distribution management for 3D TLC is necessary, in order to greatly adjust the voltage delta and charge sensing. The firmware is carefully tweaked by Apacer's engineering team to offer the greatest number of PE cycles in this format, 100,000, which is 33 times more than MLC or industrial 3D TLC. In order to maximize SSD endurance, Apacer has enhanced its SLC LiteX technology to achieve 100,000 PE cycles. Powered by carefully selected NAND components, the firmware structure is specifically optimized to enhance NAND flash stability during daily operations. And the error handling algorithm is significantly improved to avoid any unexpected ECC errors. The result is a prolonged SSD lifespan. The advantages of SLC LiteX are obvious. Endurance, as I said, is 33 times more as compared to conventional 3D TLC, while costs are down by 86 to 92% as compared to SLC. Now, users will be able to purchase an SSD which has the most suitable characteristics for their application. Let's move on to signed firmware. Signed firmware is a protective mechanism on the authenticity of a firmware package. There are some applications that are very sensitive, not only to data, but to backdoors and viruses as well. Signed firmware encrypts itself with special algorithms. If any modifications are made to the firmware contents, the SSD will not be able to function any longer. So how does it work? When Apacer develops a new model that supports signed firmware, the first step is to create firmware raw data and generate a private key. The next step is to use third generation SHA-256, which are secured hash algorithms, to encrypt firmware raw data, and simultaneously using a private key to generate another public key. The third step is to combine the firmware hash code with the private key's prime number, not the actual private key, to create a digital signature. The public key will also generate a hash code on its own. The fourth step is to integrate the firmware hash, public key hash, and digital signature and turn them into a complete firmware package so that we can load it into our SSD. If a user wants to perform a firmware upgrade, they will receive a new firmware from Apacer, which is already signed. The first process is to decrypt two sets of hash codes, and the original data of the firmware raw data and public key information can be retrieved. The second step is to compare the public key with the digital signature that has already been stored in the Apacer SSD. Once they are confirmed to match, the new firmware can now be loaded onto the SSD. Core Snapshot is our next technology to discuss. Apacer's SSD monitoring system is called the Double-Barreled Solution Cloud Edition, or DBSCE. It monitors and analyzes SSD workloads in systems so that it can suggest the ideal drive for each job. Later, it can notify operators of SSD failures before they happen, so that old or damaged drives can be replaced with new ones and data integrity protected. It partners well with Apacer's SV25C Cloud Series SSDs, and also supports the Core Snapshot system, which allows for data and OS backup and recovery. Core Analyzer 2 is a very powerful tool developed by Apacer. It records SSD behavior up to 7 days, so we can trace back and understand how an SSD performed. And don't worry, none of the user data will be recorded. It only records command types. Users don't have to initialize anything. Core Analyzer will operate on its own when the SSD is powered on. Once a log file is dumped by a user, they can send it back to Apacer. We will load it to our Core Analyzer, and it will be illustrated as the image you see now. Please note that this software will mainly be operated by Apacer's R&D and generate a report when workload is analyzed. User will use another utility to dump log files. In host behavior, the user will be able to see total command read-write percentage, total sector read-write percentage, and counts of total idle, standby, flush, or trim. This can help us judge whether platform behavior is write-intensive, read-intensive, or not critical at all. Second tab is the access behavior. It shows the distribution of sequential or random access patterns, file size of read and write, and whether files are 4K aligned. Third tab is operation behavior. This page indicates an SSD's health status. It shows the increasing curve of average erase counts, total power cycle counts, and thermal history. These three factors can greatly influence an SSD's lifespan, which is why we thought it's essential to keep track of them. Apacer works with leading platform providers such as Advantech and Alxon to seamlessly integrate our SSD monitoring software into their existing software suites. This gives customers more options. Here you can see Apacer's core snapshot backup and recovery functions as they'd appear when running inside Alxon's software platform. At Apacer, we often say, an SSD is like a tire. Both will wear out eventually. But if you could know in advance that your tire was going to pop, you could avoid a serious accident. DBSCE basically does this. It can be set to send alerts or notices when situations such as an undetectable SSD occur. Those can be sent to administrators who are out of office using common social media apps like Line or WhatsApp or via SMS and email. Whatever's the most convenient way to contact your team members. As for Core Snapshot, it's a system disaster's savior. It's highly compatible with all operating systems and can back up and subsequently recover not only an OS, but also all data on an SSD. But what's most impressive is that it can carry out the entire recovery process in just 1 second. That covers all our value-added features. Our next topic will be some use cases. These are real-world scenarios where our customers adopted our solutions and we helped them resolve crucial problems. One customer was a manufacturer of 5G switches. Their challenges included keeping hackers out, a write-intensive application, and a non-standard OS. Apacer was able to assist them by customizing our monitoring UI. The operational lifespans of SSDs they used were extended, and the risk of attack was greatly reduced. And they were able to analyze and learn more about their SSD real-world performance data, thanks to the assistance of Apacer's Core Analyzer technology. A second customer was making 5G base stations. They came to us looking for SSDs and DRAM that could function normally, even in harsh environments. They also needed to tweak certain parameters carefully. Apacer helped meet their needs via multi-party testing and verification, as well as careful signal adjustment. In the end, stability was strengthened, and cost effectiveness was maximized. And a third customer was involved in the creation of 5G wireless networks. They were looking for extremely high stability and environmental tolerance. They also needed to be able to carry out cost-effective upgrades, and were using a non-standard Linux OS. Apacer was able to help by offering an anti-sulfuration SSD similar to the ones we described earlier. This greatly improved the durability and reliability of their system without requiring a motherboard redesign. The customer was very satisfied with the final result. Finally, we'd like to talk a little bit about Apacer's core strengths. Here's an overview of Apacer's strong points. Apacer's industrial SSDs and DRAM strengthened vertical integration. Applications: IoT, server and networking, transportation, defense, gaming, healthcare, and smart factories. Customers respect our deep hardware and firmware know-how. Rigorous quality assistance. In-house testing. Fixed BOM means long-term reliability. Responsive FAE including on-location visits. Our extensive experience makes us an ideal partner. Thanks so much for taking the time to listen to our presentation. Goodbye.